In the last video we finished the on-screen display, but we need those player scores. The score section can be broken up into two main parts. The points per brick counter, which drives the player score accumulators. We went over all this logic in detail in part 12, so we won't redo that here. I'll start a new file for this module. For inputs, we'll need brick hit, can hit bricks, attract, start game, player 2, S clock, set bricks, 2 Henry, 8 Henry, and 16 Henry. She puts out count, RAM player 1, and the 2 score counters. We do need to make the 74160 decade counters, but for the 74192, we'll just use the 74193 we already made. This device uses a down counter and is only loaded to a max of 7, so either part will work. For the physical boards, we noted that you can use the 193 as an alternative. 192s are also pretty hard to find, especially the real ones. If you really want to make and use a 192 here, that would be a good exercise for you. I'm too lazy. Another change we'll make is in the load signal generator. Using a one-shot in this configuration without a timing capacitor creates a short pulse depending on parasitic capacitance and layout particulars. We're going to replace this with a more stable SR latch with the same trigger criteria and reset on the fall of clock. If you remember, brick hit rises on CKBH and clock drops shortly after. This latch will therefore generate a nice short load pulse without us needing to do some strange one-off timer. You can see right away that we're going to have a loop warning for this path. We'll build it this way first and see what happens. Let's go make that 74160. It's not always a good idea, but I'm going to copy this from our 74161 and modify. For counting, we can't simply roll over like we could for a binary counter. We bump up only if we're below the decimal max. Otherwise, we start over at 0. We also need to turn on TC when the counter hits decimal max. We could also make a generic 7416X using parameters to define the count limit. You specify a parameter using this strange syntax. I'll add a max parameter with a default of 15 for a 163. We then use that parameter in the 2 checks. When you instantiate, you can just ignore the parameter to get the default 163 type behavior, or you can specify a max of 9 to get a 160. We can also make this more generic by adding a size parameter to specify the bit width. By default, this would be a 163, but you can go nuts. If you only care about binary counting, you can trash the max parameter and set the max limit based on the bit width. I'm just going to use the dedicated 160, but I wanted to show that parameterized options exist. Alright, let's go wire it up. I'll start with RAM player 1. This really should have been generated in the brick section and brought over here as player 1. I'll do that load generator SR latch. Then add the 193. We're not using data out or carry, but we'll need the borrow outline, so I'll add a wire for that. Generate those count signals. And finally, we can add the score counters. We need loose wires to bring out and chain the TC outputs from the first 2 stages. and we can directly drive the appropriate bits of the score outputs from each counter. Now the tens digit. Chain that from the previous counter. Then the 100s. Nothing else has changed, so we don't need TC here or need the wire. Copy those three and modify for player 2. Not always a good idea, but I'm lazy. Probably bite me in the oscilloscope later. That should do it. Copy that signature and drop into main. Create the output wires and connect it up. It's nice to finally have everything. We can now send the real scores to the on-screen display. And we now have RAM player 1 for the bricks instance. The count line will be used later for the sound module. Oops, forgot we needed that clock line. Better. Build that. And yep, she pukes. Exactly what we expected. We've got a few loop breaking options. We can add a delay to borrow out or add a delay to the down input. I think I'll delay borrow out and see if we have any issues. I'll create the delayed borrow out using a cheap D-type flip-flop with the inverted clock and the original borrow out. Now use the delayed line. That's really active low. Fix that. Build is now clean, so let's turn this on and see if it works. I turned on balls forever and disabled paddle shrinkage. That's a new term. The first 2 rows should give 1 point per brick. Yep. Rows 3 and 4 should give 3. Rows 5 and 6 are 5 points. And the last 2 rows should give us 7 points per brick. Perfect. I didn't really expect that to work on the first shot. Clear all the bricks and we should get 448. Yep, exactly. Start a 2-player game. Ignore player 1. And player 2's score does not bump. Well, that's not going to work. Yep, that's what I get for copying. Try that again. Start a 2-player game. Bypass player 1. And she bumps. We should at least test that each digit bumps properly. Well, this is great. Today we successfully added the player scores. Now that we have all of the UI elements working, we need to make some noise, so we'll build the sound module next. I'll see you over there in a bit.